Guys, welcome back to my channel Science Learning Gateway. So today in this video we are going to learn about how to write the electronic configuration of the first 20 element, and also we will learn that how to find the valencies of the elements. In my last video from basics of chemistry, if you have not seen that video, I will provide the link in the description box. You can see that, you can watch that video. In that I have explained how to learn the atomic numbers from 1 to 20 in a sequence manner. Then also I have uh, explained that the symbols of the elements, means how we can learn the symbols of the elements, how we can learn the atomic number of the element. If you don't know the atomic number of the elements, then you can't write the electronic configuration. So it's very important to learn the atomic number first. For that you have to go through that video, which I will provide in the end screen also, and also in the link I will provide in the description box. You can watch that. So let's start with writing the electronic configuration and also to find the valencies of the elements. So let's start our discussion from there. But before that, we should know about the structure of the atom, means how an atom looks, what are the subatomic particles which are present in the atom. We all know that in an atom electrons are present, electrons, protons and neutrons are present, right? Means these are the three subatomic particles which are present inside an atom. Electrons are negatively charged particles, protons are positively charged particles, and our neutrons don't have any charge. So if electrons and protons have only charge and neutron doesn't have any charge, so atom as a whole is electrically neutral, because number of electrons is always equal to number of protons in an atom. Means total number of negative charge is always equal to total number of positive charge. So atom as a whole is electrically neutral. Many times the question is asked that why atom is electrically neutral. So what we have to say, that in an atom number of electron is equal to number of protons, that is total number of negative charge is equal to total number of positive charge. So atom as a whole is electrically neutral. Okay, if you look at the structure of the atom, in the center you will see a positively charged center is there, that is called nucleus. Okay, inside the atom, in the center, nucleus is present, and in the nucleus which subatomic particles are present? Inside the nucleus, protons as well as neutrons are present. Since protons are having positive charge, neutrons doesn't have any charge, so nucleus is positively charged species, right? So what is a nucleus? Nucleus is present in the center of the atom, which contains protons and neutrons, and it is positively charged, right? Now around the nucleus we have the orbits or shells. So what are orbits or shells? These are the imaginary path in which the electrons revolve around. So we have different types of shells, and shells, or you can say orbit, depending on the element, right? And in these orbits or shell, electrons revolved. See, you can see the electrons, they revolve in these orbits or shell. So we have different shells, and the name of the shells are given like K, L, M and N, and so on. The first shell, which is close to the nucleus, is called the K shell. The second shell is L shell, third shell is M, fourth one is N, and after that if any other shell will be there, then it will be K, L, M, N, O, and after that it will be P, right? So according to that you have to remember the shell, but the first shell you should remember is that after the nucleus the first shell is a K shell. Okay, and for that we used to give number 1, means that is the first shell. For L we used to give 2, for M 3, and the fourth one is, and the N is the fourth shell. Now we should learn that how we can means how many electrons should be present in each of the shell. It's not that like that, no, कि जितने भी इलेक्ट्रॉन्स मन किया तो एक ही शेल में रिवॉल्व होने लगेंगे, ऐसा तो हो नहीं सकता है. एक पर्टिकुलर नंबर होता है जो एक पर्टिकुलर शेल में इलेक्ट्रॉन्स रिवॉल्व होते हैं. तो फॉर दैट बोर हैज़ गिवन एन एटॉमिक मॉडल, एंड ही हैज़ ऑल्सो गिवन अ फॉर्मूला टू कैलकुलेट द नंबर ऑफ इलेक्ट्रॉन्स विच कैन बी प्रेजेंट इन ईच ऑफ द शेल, एंड दैट formula is 2n square. This is a formula by which we can calculate at how many electrons can be present in a shell. Like for example, मैं आपको एक example देती हूँ. Suppose आपकी क्लास में एक bench है, right? तो उस bench में two students can sit comfortably, right? Two students, they can sit comfortably, but suppose if one more student will come, then for you people it's difficult to sit in that bench, right? Because this is a space for only two students. So in the same way, ये जो ऑर्बिट्स या शेल्स होते हैं, इसके भी अपने पर्टिकुलर नंबर ऑफ इलेक्ट्रॉन्स हैं, उससे ज़्यादा वो अकोमोडेट नहीं कर सकते. तो नाउ लेट्स सी दैट इन ईच ऑफ द सेल हाउ मेनी इलेक्ट्रॉन्स कैन बी प्रेजेंट. तो लेट्स स्टार्ट विद द के शेल. फॉर के शेल वी यूज टू टेक द इंटीजर नंबर n इज इक्वल टू 1, ठीक है, बिकॉज इट इज़ अ फर्स्ट शेल. तो अभी हम वो फॉर्मूला लगाएंगे 2n² वाला. तो 2 फॉर k द वैल्यू ऑफ n इज़ 1, तो विल पुट 1 over there and we'll put square. So 2 into 1 square is again 1. So the value of so the number of electrons which can be present in the K shell is 2. Like आपके स्कूल में जो बेंच है उसमें 2 स्टूडेंट बैठते हैं ना, उसी तरह से K shell में सिर्फ 2 electrons can be present, not more than that. Now let's take the example for L shell. For L shell, the value of n is equal to 2. Now we'll put the formula 2n square. 2 into 2 square. So 2 into 2 square is 4. तो 2 4s are 8. So L shell में हमारे पास total number of electrons हो जाएंगे 8. Not more than that. Suppose there is a small classroom. In that only 8 students can sit comfortably. If 2 or 3 students will come from any other section or from any other class, you people will not feel good. Means you don't have a proper space to sit in that area, right? In the same way, in L shell, not more than 8 electrons can be present. Okay, it will not allow the extra electron to come to its place. Now let's discuss for KL M shell. For M shell, the value of n is equal to 3. Now we'll write 2n square. Means 2 into, in the place of n we will put 3. 3 3s are 9. 2 into 9, that is 18 electrons. So हमारे KLM shell में 18 electrons present होंगे. In the same way, for N shell, we'll take the value of n as 4 and we'll put the formula 2n square. So 2 into 4 square. 2 into 16. 16 into 2 is 32. So हमारे N shell में total electrons हो जाएंगे 32. You can see the number of electrons which can present in each of the shell. In K shell, 2 electrons can be present. In L shell, 8 electrons can be present. In M shell, 18 electrons and in N shell, 30 electrons is present. Not more than that. ठीक है. अगर आपको एग्जाम में क्वेश्चन पूछा जाता है कि फाइंड द नंबर ऑफ इलेक्ट्रॉन्स विच कैन बी प्रेजेंट इन ईच ऑफ द शेल, तो यू हैव टू यूज द फॉर्मूला 2n square. You'll use this formula and you'll find that how many electrons can be present in each of the shell. K shell में 2 electron, L shell में 8 electrons, in M shell 18 electrons and in N shell we have 32 electrons. But now one more question is there. See, you know about the noble gases. Noble gases have 2 or 8 electron in the outermost shell. Means they are very stable in these electronic configuration. राइट. सो जितने भी एटम्स होते हैं, अगर उनके आउटर मोस्ट शेल में 2 या 8 इलेक्ट्रॉन्स होते हैं, then they are said to be stable. Then they have a stable electronic configuration. So all the shell, they should not have more than 2 or 8 electrons. If they will have 2 or 8 electrons, then they will be in the most stable state. That's why चाहे वो K shell हो, चाहे L shell हो, चाहे M हो या N हो, in all these cells 2, K में तो 2 रहेगा, उससे ज़्यादा नहीं रहेगा. L M N में 8 electrons, not more than that. Because if they will have more electrons, then they are not so stable, right? Means to achieve the noble gas configuration, the element should have 2 or 8 electron in the outermost shell. Then only they will be stable. So I think you have got a basic idea about the structure of atom, that an atom consists of electrons, protons and neutrons. Inside the nucleus, protons and neutrons are present. Protons are positively charged species, neutrons are neutral species. So nucleus as a whole is positive charge. Now around the nucleus we have orbits or shells in which electrons revolve. Electrons are negatively charged species. But ये जो orbits और shells होते हैं, ये different types के होते हैं according to an atom. For example, हाइड्रोजन में बस एक ही ऑर्बिट है, बिकॉज उनके पास तो बस एक ही इलेक्ट्रॉन है ना. हीलियम के पास भी बस एक ऑर्बिट है, बिकॉज हीलियम ऑल्सो कंटेन्स ओनली 2 electrons. नाउ वी हैव लिथियम. इन लिथियम 2 shells are present, KLN. In K shell 2 electrons and in L shell one electron will be present. So depending on the atomic number of their elements, the number of shells also increase. So the first shell which is close to the nucleus is the K shell, second is the L shell, third is M shell, and the fourth one is N shell. And how you will calculate the number of electrons in an atom? You will calculate the number of electrons in an atom by using the formula 2m square. Now, now let's learn about how to write the electronic configuration of the elements. Okay, so for that we'll start with the first element, hydrogen. In the last video, I have told you what was the symbol of hydrogen. If you all remember, you all know, I know, the symbol of hydrogen is H, capital H, and its atomic number is 1. Right? So if it is having only one electron in the outermost shell, then that electron is present in which shell? It is present in the K shell. Right? Suppose this is a nucleus. In that nucleus, proton is present. We know that in an atom, number of proton is always equal to number of electron. So if atomic number is 1, which is equal to the two number of proton, then there will be one proton in the nucleus and one electron in the K shell. Right? So this is the structure of an hydrogen atom. One proton will be present in the nucleus and one electron will be present in the K shell. So what will be the valency of hydrogen? It can be plus minus 1, because we know that it's a non-metal, but still the confusion is there for hydrogen. Its proper place is not assigned to it. Right? Means it's not considered as a metal or a non-metal, but mostly we consider it as a non-metal, and its valency is 1. Now let's talk about helium. Helium is a noble gas, right? It's a noble gas present in group number 18. The atomic number of helium is 2 and its symbol is He, capital H and small e. Since 2 electrons or 2 protons are present in the helium, 2 protons will be present in the nucleus. This is the nucleus in which 2 protons are present, and this is the outermost orbit in which 2 electrons will revolve. Okay? You know what is atomic number? Definition of atomic number is equal to number of protons present in an atom, and we know that number of proton is always equal to number of electron in an atom. So if 2 protons are present in helium, 2 electrons will be present. So that 2 electrons will be present in the K shell, because we know that in K shell 2 electrons can be present, not more than that. Okay, since it is having 2 electron in the outermost shell, it is in the stable state. It will not donate this electron, neither it will accept electron. So its valency will be 0. You have to remember that if an element have 2 or 8 electron in the outermost shell, its valency will be 0, because it will not donate or accept any electron, and it will come in the category of noble gas. The third one is our lithium. Lithium, the symbol of lithium is Li, capital L and small I. Atomic number is 3. So if 3 atomic number is there, 3 protons and 3 electrons, 3 protons will be present in the nucleus and 2 electron will be present in the K shell, not more than that. Then after that, one more electron we have to put in the L shell. Since one electron is present in the L shell, this electron can be easily donated to any other element. Right? So lithium will donate this electron to become stable. To attain the noble gas configuration, it will donate that electron, and it will occupy a valency of +1. Since it is giving one electron to any other element, it will occupy +1 valency, and it is a metal. We know that metals are electropositive elements which can donate electrons, which can donate 1, 2 or 3 electrons. If the elements have 1, 2 or 3 electron in the outermost shell, they are considered as a metal. Now the second one is beryllium. The symbol of beryllium is Be, capital B, small e. Atomic number is 4. 4 protons and 4 electrons. So 4 protons will be present in the nucleus and 4 electrons, 2 electrons in the K shell and 2 electrons in the L shell. Right? So since 2 electrons are present in the L shell, these electrons can be donated to any other element. Right? So it will be having +2 valency, and it is a metal. The third one we have boron with the symbol capital B, and atomic number is 5. Electronic configuration 2 and 3. Since 3 electrons are present in the outermost shell, it will donate that 3 electron to become stable, and boron will come in the category of a metalloid, which have some properties of metals and some properties of non-metal. Now we have carbon. Atomic number of carbon is capital C. Atomic number is 6. So 6 protons and 6 electrons, 6 proton in the nucleus and 6 electron in the shells. 2 will be in the K shell, and after that 6 minus 2, 4 electrons are left that are present in the L shell. So these 4 electrons can be shared with the other element to become stable. So carbon is a non-metal. If we will see that carbon generally makes covalent bond, and covalent bond is formed by the sharing of electrons. So what carbon will do, neither it will gain 4 electron nor it will share, nor it will donate 4 electron. It will share its electron with any other element. Either it can share its electron with carbon, with oxygen, or with nitrogen, right, to form any other compound and to become stable, and carbon is a nonmetal. Next we have nitrogen, atomic number 7, and its symbol is capital N. 7 protons, 7 electrons. 7 protons are in the nucleus and 7 electrons revolve around it. So 2 we will fill in the K shell, then 7 minus 2, 5 electrons are left that will be present in the L shell. So these now this nitrogen is having 5 electrons, so it cannot donate 5 electrons, because for donating 5 electrons it needs a large amount of energy. So what it will do, it will accept electron from any other element to become stable. So how many electrons it needs to become stable? It needs 3 more electrons to become stable, because to attain noble gas configuration it should have 8 electrons in the outermost shell. So 8 minus 5, how many electrons are left? 3. So it needs 3 electrons to become stable. So what it will do, it will accept 3 electrons from any other element. So it will have a valency of -3 and it is a non-metal. Now let's come to oxygen. Atomic number of oxygen is 8 and its symbol is capital O. So 8 protons and 8 electrons. 2 electrons will go in the K shell. 8 minus 2, 6 electrons are left that will be present in the L shell. Now it is having 6 electron in the outermost shell. How many electron it needs to become stable? It needs 2 more electrons to become stable. 8 minus 2, that is 2. So it will have -2 valency and it is a non-metal. Next we have fluorine, capital F, atomic number 9. So 9 protons, 9 electrons, 9 protons in the nucleus and 9 electrons will revolve around the nucleus. So 2 will be present in the K shell, 9 minus 2, 7 electrons are left that are present in the L shell. So it is having 7 electron in the outermost shell. How many electron it needs to become stable? It needs only 1 electron to become stable. To make it 8, it needs 1 electron. So it will have a valency of -1 and it is a non-metal. Now let's come to neon, which is a noble gas. Symbol of neon is Ne, atomic number is 10, and if we write the electronic configuration it is 2, 8, right? Because 10 protons are present and 10 electrons are present. 2 electrons will go in the K shell and remaining 8 electrons will go in the L shell. It is having 8 electron in the outermost shell, so it is present in its most stable state. So what will be its valency? It is 0, because it will neither gain the electrons, neither it will accept the electron. So it is a noble gas. Now let's come to the next element, that is sodium, atomic number 11. Yeah, sodium is having atomic number 11 and its symbol is Na, because its Latin name is natrium. According to that, it is getting its symbol Na. So since 11 electrons are present in sodium and 11 protons, so 2 electron will go in the K shell, then 8 electron will be present in the L shell, not more than that, because we know that in L shell only 8 electrons are present. The remaining 1 electron will occupy the M shell. So since this electron can be donated to any other element to become stable, sodium will have a valency of +1 and it is a metal. Next we have magnesium, atomic number 12, and the symbol is Mg, capital M and small g. So these 12 electrons we have to distribute in different shell. So 2 electron will go in the K shell, 2 electron in the L shell and 2 electron in the M shell. Now these 2 electrons are the extra electron which can be donated to any other element to become stable. So what magnesium will do? It will donate its 2 electron to become stable and it is a metal. Next we have aluminium, atomic number 13, and the symbol is Al, capital A and small a. Electronic configuration is 2, 8 and 3. So in the outermost shell 3 electrons are present which can be donated to any other element to become stable. So these 3 electrons which are present in the outermost shell will be donated to any other element to become stable. So its valency is +3 and aluminium is also a metal. Next we have silicon, Si, atomic number 14. Electronic configuration is 2, 8 and 4. In the outermost shell, 4 electrons are present. So these 4 electrons can be shared with any other element, right? To become stable. So it is having a valency of 4, and silicon is a metalloid which has some properties of metals and some properties of non-metals. Next we have phosphorus, atomic number 15, symbol is P. So 15 electrons we have to distribute in different shell, 2 in the K shell, 8 in the M shell, and the remaining 5 will go in the M shell. But this 5 electrons cannot be donated because it needs a large amount of energy to donate 5 electrons. So how many electrons it needs to become stable? 3 electrons, right? 5 plus 3, that is 8, means 3 electrons it will accept. So it will have a valency of -3, and phosphorus is a non-metal. Next we have sulfur, atomic number 16, and the symbol is capital S. Electronic configuration 286. So 6 electron it is having in the outermost shell. So how many more electron it needs to become stable? It needs 2 more electron to become stable. So it will accept 2 electrons. So it will have a valency of -2, and it is a non-metal. Next we have chlorine, atomic number 17. Electronic configuration 2, 8 and 7. 7 electron in the outermost shell. So it will accept how many electrons to become stable? It will accept only 1 electron. So it will have a valency of -1, and chlorine is also a non-metal. Argon, noble gas again. So it is having atomic number of 18, and the symbol is Ar. Electronic configuration 288. You can see 8 electrons are present in the outermost shell. So it will have how many valencies? Its valency will be 0 because it will neither accept nor gain electron because it is present in its most stable state. So it will have a valency of 0, and it's a noble gas. Potassium, atomic number 19, and the symbol is K. So 19 electrons we have to distribute in the different shell. So 2 electron in the K shell, 8 in the L shell, M in M 8 electrons, and in L shell only 1 electron. So this 1 electron has to be removed so that potassium will become stable. So it will donate 1 electron to become stable, and it is a metal, and it will have a valency of +1. And the last means that the element with atomic number 20 is calcium with capital C and A symbol, and we have to distribute the 20 electrons. So its electronic configuration will be 2882. In the N shell you can see 2 electrons are present. These 2 electrons have to be removed so that calcium will become stable. So calcium will donate these 2 electrons to become stable, and calcium is a metal. So remember guys that in the K shell only 2 electrons will be present. In L shell 8 electrons will be present, and in other shells also like M and though 18 and 32 electrons they can occupy, but they will be more stable when they have 8 electrons in the outermost shell. So always see that whether the elements are having 8 electron or 2 electron in the K shell. So if you have to place the same number of 2 or 8 electrons in the outermost shell, and you have to remove the extra electrons, so that extra electron will be the valency. And if they are having less electrons, means they are having 5, 6 or 7 electron in the outermost shell, then the elements will gain electron. Those are the non-metal. They will gain electron to complete their octet, and they will become stable. So I hope you all have learned how to write the electronic configuration and how to find the valency. So just let us do one example so that you will understand it more clearly. Let us take the element magnesium. Atomic number of magnesium is 12. So first of all, let's write its valency. 2 electron in the K shell, 8 electron in the L shell. So 12 minus 10, 8 plus 2 is 10. So 2 electrons are left, that 2 electrons will put in the M shell. So what we can see that these 2 electrons we have to remove so that magnesium will become stable. So magnesium will remove these 2 electrons, means it will donate these 2 electrons to any other element. So magnesium will occupy a valency of +2 because it is donating 2 electrons. Right? So like this you will find the valency. Now let's take an example for a nonmetal also. So the most common nonmetal, let's take for chlorine. Atomic number is 17. Electronic configuration 2, 8, 7. You can see in the outermost shell 7 electrons are present. It needs 1 more electron to become stable. So it will accept 1 electron, and it will occupy a valency of 2, 8, 8. So it has accepted 1 electron only, no? So the chlorine will have a valency of -1. So like this you will find the valency and you will write the electronic configuration. I hope you all have understood this. Go through both the videos of basic concepts of chemistry to score good marks in chemistry, and these are the basic fundamentals of chemistry. In the next tutorial I will tell you how to find the number of neutrons, how to write the mass number. Those things are also important because many times the questions are asked, if an element X is having atomic number 12, how many neutrons does it have, how many electrons does it have? So those things you should know, right? And without knowing the number of neutrons you cannot find the mass number. So we will do, in the next tutorial we will do number of neutrons and mass number. So thank you guys for watching my channel. Please do please hit the like button, share it with your friends, and if you have not subscribed to the channel, do subscribe it for more interesting videos from chemistry and from your syllabus. So thank you for watching.